Okay, this is the second part of the lesson on reference angles, and what we're going to be doing in this one is, instead of discovering about reference angles, what we're going to do is we're going to go ahead and start using reference angles to accomplish some specific tasks, such as finding angles in the coordinate plane. So here we go. Finding theta. So we're going to find theta if sine of theta is equal to our value here, okay? And theta is going to be in quadrant 3, and that means that it's between 0 and 360. So let's do this. First, we need to understand what this is actually saying. If the sine of theta is equal to negative 0.5592, then what we are going to do is we are going to find theta by saying theta is equal to the inverse sine of negative 0.5592. And what this is going to do is this is going to give us a theta, but really it's going to be a theta hat because it's going to give us an angle. So now what we found is that theta is equal to, we're going to take this and it's going to be actually equal to theta hat, because remember, our theta actually has some very specific guidelines that it has to fit in. It has to be in the third quadrant. And so when we actually do this inverse sine, we get that it's equal to negative 34 degrees. And if it's in quadrant 3, that means it's over here. So theta hat is going to be 34 degrees. And so when I draw this, it's going to look something like this. Third quadrant. And this is going to be my 34 here. And so if I'm looking logically at what this means that I have to go all the way around to get to here. And so that's going to be 180 plus 34 is 214 degrees. Okay? You see how that works? So I used my sine to find my theta hat, and I added it to whatever I needed to add it to in order to get my reference angle, to use my reference angle to get my theta. Okay, and so let's try another one here. Find theta to the nearest tenth. Okay, so I'm going to have nearest tenth of a degree if tangent theta is equal to negative. So I'm going here. Once again, we're going to go inverse ratio of negative negative 0.8541, and so that's going to be my theta hat. So that means that my theta hat is going to be equal to 40.5 when I put that into my calculator. Okay, so that's going to be my 40.5. Now, when I draw this, that was terrible. Select it, erase it. Let's start over. We're going to go here. Whoops, technical difficulties. Not much better, but we're working with it. Okay, so if my theta is 40.5, okay, that's my reference angle. And if it's 40.5, we're noticing that we are in the fourth quadrant. So that's going to be here. That's my 40.5 degrees there. Well, that's my 40.5. I know that I'm going to have the whole way around 360 minus 40.5, because if I went all the way around like this and I go back 40.5 degrees, I'm going to end up with 319.5 degrees. Okay, this is how this works. It's really pretty simple because we just need to remember that we're finding theta hat. And so go ahead and try this one on your own. And if you need a little bit of guidance, I'm going to go ahead and be right here. I'm going to go ahead and do it. If you want to pause, that's perfectly fine. So I'm going to go this way. Sine inverse of negative 1/2. And when I do my sine inverse, I'm going to get 30 degrees. Okay? And once again, we're going to go this way. And I'm going to notice, I've been switching some colors. If I'm in the third quadrant, I'm down here. This is going to be my 30 here. So that means that I'm going to have 180 plus 30 is 210 degrees. It's important that we recognize this right here. So if the sine is negative, and I've got to match it up with this. Theta is still within 360. My 210 is within my 360. Okay? Here's another example. It's a secant. If we've got a secant here, let's look at what we've got. Secant of theta is equal to one over cosine theta. So that's equal to 1 over 1 over 3.8637. Because this is going to be my cosine theta. This is actually what we're going to convert this to. Because I know that secant is 1 over cosine. So that means that cosine is 1 over secant theta. So that's where I'm right here now. Okay, and so this is going to give me a decimal value. When I come up with that decimal value, what I'm going to do is I'm going to put that into my function. Okay, and it's going to look something like this. So we're going to get theta hat is equal to, it's going to be 75 degrees. And along with my line of logic from before. So I've got my 75 degrees here. It's in quadrant 4. Looks something like this. So it's going to be 360 minus 75 is going to give me 285. Okay? This is my theta. Not my theta hat. Remember, when I get my theta hat, I've got to still use my reference angle appropriately. Okay? Let's try one more. Here's another cofunction. And if you want to try this one, go ahead. I'm going to go ahead and roll straight through here. I'm remembering, of course, that cotangent is related to tangent in this way. Tangent is equal to 1 over cotangent. So what I'm going to do is I'm going to take the inverse tangent of 1 divided by negative 1.6003. Okay? And when I do that, I get theta hat is equal to 32 degrees. Go ahead and draw my reference angle here. I'm in quadrant 2, so I'm here. This is 32 degrees. And so that means I'm going to have 180 minus 32 is going to give me 148 degrees. That's my theta. Okay? If you follow along with it, the important steps are to make sure that you're taking the inverse ratio, and that is theta hat. That's my theta hat. When I use my theta hat and I follow my guidelines from the previous lesson, I'm good to go. Okay? So that's something that you can do easily if you use what we've already learned. All right? That's reference angle 2, guys. We'll see you tomorrow.